Start with the work, energy and power. But before that, we'll talk about the scalar product and vector product of vectors. Okay, so this is some more maths, right? This is some more maths which will be required in this chapter, okay, next chapter, and in remaining part we can say. So let's talk about the product of vectors. So there are two types of products. One is scalar product and one is vector product of vectors. So what's the difference between them? So broadly, if you multiply two vectors and if the resultant is a scalar, if the result of the product is a scalar quantity, then it is known as a scalar product. And if you multiply two vectors and result of product is a vector quantity, then it's known as a vector product. So it's very simple, right? So let's talk about the scalar product first. So suppose for an example, you have this block, okay, big block, and you are moving it. Okay, so suppose you are moving it. So suppose I am pulling it like this. Okay, so I tie some rope to it and I pull it in this direction. Now it gets displaced along the floor. Suppose it gets displaced along the floor. So now displacement is from here to here, right? So this was its starting position and this is the end position. So this much is the displacement S. So now what I can do is I can resolve this force along two components, right? So I will resolve the force along two components. So this is the x component and this is y component, right? So the force can be written as F bar is equal to F cos theta. What is theta? Theta is the angle made by F bar with the x axis. So x component is F cos theta and y component is F sin theta. So now I am resolving the force along two components. X component is F cos theta, y component is F sin theta. So you have F cos theta multiplied by I cap. Okay, this is the x component, and F sin theta multiplied by j cap. This is the y component. And displacement can be written as, it is totally along x axis, it's along the floor. So it can be written as S into I cap, right? Now here you can say that only x component of this force is doing work and y component is not at all doing any work. This thing is clear? Yes, no? Only x component is doing work, y component is not doing work, right? So only x component of the force is doing work. Now you recall what is the definition of work. So work is equal to, we know, force multiplied by displacement, right? So force multiplied by displacement. So now I can write this work as work done by x component is force in x direction Fx multiplied by the component of displacement in x direction, right, that is S, and plus force in y direction multiplied by component of displacement in y direction, but there is no displacement in y direction, right? So see, work done can be written as, this work done can be written as work done by this x component only, that is F cos theta multiplied by S. Okay, and therefore we get this definition of work from here. Okay, work is equal to F into S multiplied by cos of theta. From here we get definition of scalar product. Okay, so what is a scalar product? You have two vectors, you multiply them, resultant is a scalar quantity. Okay, so work is a scalar quantity and it is product of force and displacement. So we denote this product by a dot and it is therefore also called as dot product. Okay, so work done is equal to F bar dot S bar, and what is F bar dot S bar then? It is F multiplied by S multiplied by cos of theta. Okay, so F bar dot S bar is equal to F multiplied by S multiplied by cos of theta. Okay, so that is magnitude of first vector into magnitude of second vector multiplied by cosine of the angle between two vectors, right? So this is the definition of dot product or scalar product of two vectors. So suppose you have two vectors, any two vectors, right? So A bar and B bar are two vectors, angle between them is theta, then the dot product is represented by, or scalar product is represented by A bar dot B bar. Okay, that means when you multiply them, resultant is a scalar quantity. So it's equal to magnitude of first vector into magnitude of second vector multiplied by cos of the angle between two. So this is the scalar product. right? Okay, this is clear? Yes, no? All right, good. Then now what we'll do is we'll represent this A bar and B bar in the resolved form. Okay, so A bar I will represent as Ax into I cap plus Ay times J cap plus Az into K cap. Okay, so by their x, y and z component. B bar similarly I will represent as Bx multiplied by I cap plus By times J cap plus Bz times K cap. Okay, so I have represented A bar and B bar in the resolved form, okay, in form of their components along x, y and z axis, right? So then now see, I want to multiply A bar and B bar. I want to take their scalar product. So for that I need to know what is the scalar product of these unit vectors, okay, I cap, J cap, K cap. Okay, so let's take scalar product of unit vectors. So if you take I cap dot I cap, so what is the scalar product of them? So magnitude of I cap is 1, magnitude of second I cap is also 1 because they are unit vectors. And what's the angle between I cap and I cap? So it's the same vector, right? That means angle is 0. So you have cos of 0, right? This is definition of scalar product A B cos of cos of theta. So theta is equal to 0 here. Okay, so cos 0 is 1 and therefore the result is equal to 1. Similarly, you have J cap dot J cap is equal to 1. Similarly, you have K cap dot K cap also equal to 1. Okay, and if you multiply I cap with J cap, what do you get? I cap dot J cap is equal to magnitude of this one is 1, that is magnitude of I cap is 1, magnitude of J cap is 1 and cos of the angle between them. So what's the angle between them? It's 90 degrees and cos of 90 we know it is equal to 0 and therefore you have I cap dot J cap is equal to 0. Okay. Similarly, I cap dot J cap dot K cap dot I cap, it's all equal to 0. Okay, and in reverse order also, if you take J cap dot I cap, okay, J cap dot I cap, okay, so that will also be equal to 0, right? So that means product of two unit vectors. So product of a unit vector with itself is what? It is 1, okay, and product of two perpendicular unit vectors is equal to what? It's equal to 0. But which product? Scalar product. Scalar product of a unit vector with itself, it is equal to 1, and scalar product of a unit vector with a perpendicular unit vector is equal to 0, right? So if we use this thing, then we can write A bar dot B bar is equal to, just write A bar in the resolved form, okay, in terms of components, B bar in terms of components, and when you multiply this with this, the result will be equal to Ax Bx plus Ay By plus Az Bz. How? So if you multiply this with this, okay, let's take Ax into I cap multiplied with this bracket. So you get Ax Bx I cap dot I cap. So you have I cap dot I cap is equal to what? 1. Then, okay, so then what is the result? It's Ax Bx. Then if you multiply this with this, then what do you get? Ax By I cap dot J cap. And what is I cap dot J cap? It's equal to 0. So that term will vanish. Okay, then you take Ax into I cap dot Bz into K cap. So you have Ax Bz I cap dot K cap, and that is also equal to 0. So which terms remains here? Which term survives? It is Ax Bx. I cap dot I cap, it's equal to 1. Right? Similarly, when you multiply this with this whole bracket, okay, Ay By will only survive. Right? This with the whole bracket, Az Bz will only survive. Okay, so this is therefore the dot product or the scalar product of A bar and B bar. Okay, so it is Ax Bx plus Ay By plus Az Bz. This thing is clear, everyone? Right? Good. So then now just based upon this thing, let us see some problems. So a particle moves from a point this point to this point. When a force of 4 I cap plus 3 j cap Newton is applied, how much work has been done by the force? Tell me. How much work has been done by the force? This is the question. So what is the force? Let's write the force. Force is equal to 4 I cap plus 3 j cap, right? Then you have initial position vector. So it moves from this point to this point, right? So initially it was at r1 bar, so that is minus 2 I cap plus 5 j cap, okay, and it moves to the point r2 bar, and that is 4 j cap plus 3 k cap, okay. So what's the displacement? Therefore displacement s bar is equal to what? You can say final position vector r2 bar minus initial position vector r1 bar, and that is equal to subtract r1 bar from this one. So there is no I cap, or there is no x component here, or let me just write 4 j cap plus 3 k cap minus 2 I cap plus 5 j cap, okay. So that is minus to minus, negative becomes positive, so you have 2 I cap, then 4 j cap minus 5 j cap is minus j cap minus 1 j cap, 3 k cap minus, there is no z component, so plus 3 k cap. So this is your displacement, and therefore what is the work done? So work done is just equal to F bar dot S bar, and that is 4 I cap plus 3 j cap, right? It's dot product with 2 I cap minus j cap plus 3 k cap, okay. So x component with x component, so 4 times 2, right? Product of x with x plus y component with y component, so there is 3 times minus 1, okay. Y component of this is 3, y component of this one is minus 1, and there is no z component, so plus 0 you can say, okay. So that is equal to 4 times 2 is 8 minus 3, so it is 5, right? 5 joules, okay. So if this thing is in Newton, force is in Newton, and now the unit of this is not given, okay. So they should have written that unit of that thing, it's in meters. That thing means what? Unit of displacement, it's in meters, okay. So this is clear? Yes, no? Right? Okay, so this is the answer. Very simple, right? So this was from NEET 2016. Okay, let's see next one. A uniform force 3 I cap plus 3 I cap plus j cap Newton acts on a particle of mass 2 kg. A uniform force 3 I cap plus j cap Newton acts on a particle of mass 2 kg. Hence the particle is displaced from this position to this position, okay, from position 2 I cap plus k cap to position 4 I cap plus 3 j cap minus k cap meter. The work done by the force on a particle is, so that is similar to last one. So work done is, we can directly say that it is F bar dot S bar, and that is, what is F bar? It is 3 I cap plus j cap. So when you will solve, you will not even write this step, okay. So we will just say 3 I cap plus j cap dot, what's that? Initial position is this one, final is this one. So 4 I cap plus 3 j cap minus k cap, this is R2 bar, okay, this is R2 bar, and this one is R1 bar, right? So F bar dot displacement is R2 bar minus R1 bar. So R2 bar I have written, R1 bar is 2 I cap plus k cap, and that is 4i minus 2i is 2i cap plus 3j cap minus there is nothing, so 3j cap minus k cap is minus 2k cap, right? So 3i cap plus j cap, and that is equal to 3i cap dot I cap. What's that? 6. Okay, x component multiplied with x component, y component is 1 multiplied with y component. So 6 plus 1 into 3, that means 3 plus there is no z component, so plus 0. So that is 6 plus 3, so 9 joules. So work done is equal to 9 joules. Okay, so this is also simple. I mean, this is similar to last one. Right, there is nothing in this. Okay, good. Let's go to the next one. A body moves a distance of 10 meters along a straight line under the action of 5 Newton force. If the work done is 25 joule, then the angle between force and the direction of motion of body is. Okay, so body moves through distance of 10 meters and the force is 5 newtons. Okay, so force is 5 newton, displacement is 10 meters, and they say that work done is equal to 25 joules. So the question is, what is the angle between force and displacement? Okay, so very simple. So this is force, suppose, and this is displacement. So angle between them is theta. Then we know that work done is equal to Fs cos of theta, right? So therefore cos theta can be written as, okay, option A, let's check. Cos theta can be written as work done divided by F into S, and that is work done is 25 divided by F is 5 and S is 10. So 25 divided by 50 means 1 by 2. So cos theta is 1 by 2 means theta is equal to 60 degrees. Correct. So it is option A. Okay. So this one is very simple. Right. So everything that we are going to see today will be very simple because these are just concepts. Okay. Let's see next one. A body constrained to move in y direction is subjected to a force given by this one. The work done by this force moving the body through a distance of 10 j cap meters along y axis is. So this is very simple. So just take y component because it is moving only along y axis. Yeah. So 15 times 10 means 150, right? So it's option A, correct. Okay, so displacement is only along y axis, right? Therefore x component doesn't do any work, z component doesn't do any work, only y component is doing some work. So that is 15 j cap, this is the y component of force, multiplied by 10 j cap. Okay, so that is 15 times 10 means 150 joules. Okay, so that's very simple, right? Okay, good. Then let's see next one. When a body moves with a constant speed along a circle, no work is done on it, no acceleration is produced in it, its velocity remains constant, no force acts on it. Tell me.
No work done on it.
Why?
It's moving with a constant.
What is constant?
Gravitational force and the.
No gravity.
No.
Okay, it can be any force, no? No work. Why no work? That is the question. No work is correct. S is equal to 0. Okay. Alright. Anybody else? So suppose body moves along this circle from this point to this point. This is A and this is B, right? This is A and this is B. Then you tell me, now is the displacement 0? It moves from point A to the point B. Okay. Is the displacement 0 now? I am taking only this much part. Still work done will be equal to 0. Body only moves from A to B because the force is very good. So that is the answer. Force and displacement, they are always perpendicular. Okay. So here when body is at point A, see in what direction is it moving? Let's take very small displacement. So it is tangential. Okay. We know that velocity is tangential, means displacement is tangential. Okay. So this is very small displacement, delta S bar you can say. What's the direction of force acting on the body? So it is towards the center. So F bar, that is the force. Okay. So if you take F bar dot delta S bar, or you can call it S bar also, no problem. What is that? It is the small displacement. It is said to be infinitesimal, means with the displacement in very short time. Okay, time delta t tends to 0. Okay, or instantaneous displacement. So S bar is infinitesimal, means it is carried out in very small time. Okay, displacement, or for our understanding we'll say it is instantaneous displacement. Okay, so then it's always tangential, and therefore work done is equal to what? F bar dot S bar. So force, we know it's the centripetal force, it will be always directed towards center. So this F bar and S bar, they are always perpendicular to each other, and therefore the work done is F multiplied by S multiplied by cos of 90 degrees, cos 90 is 0, and therefore work done is equal to 0. Okay, this is the answer. No work is done on it. When a body moves with a constant speed along circle, no work is done on it. Okay, is it applicable to body moving with variable speed? No. Okay, it's not applicable. Why? Because centripetal force does not change the speed. Okay, it doesn't change the speed, right? What will change the speed? So if there is some tangential acceleration, that means there is some tangential force that will change the speed, and in that case the displacement, instantaneous displacement, and that force, if you take product of them, scalar product of them, it will not be 0. Okay, so this is applicable when a body moves with a constant speed along a circle. Right, this thing is clear, everyone? Okay, good. Let's see next one. If vectors A bar is equal to cos of omega t I cap plus sin omega t j cap, and B bar is equal to this thing, are functions of time. They are given, okay, that they are functions of time. Then the value of t at which they are orthogonal to each other is. So orthogonal means perpendicular. Okay, orthogonal means perpendicular, right? So then, okay, so they are perpendicular means, how do we check whether two vectors are perpendicular? Their scalar product would be equal to 0, right? So let me just comment it. Okay, checking, how to check if two vectors are perpendicular, if vectors are perpendicular. So if a bar dot b bar is equal to 0, means AB multiplied by cos of theta is equal to 0, means it implies that cos theta is equal to 0 and theta is equal to 90 degrees or 270 degrees. So two vectors will be perpendicular if their dot product is equal to 0, if their scalar product is equal to 0. Right? This is clear. Okay. And then if we want to check if two vectors are parallel, how to check if two vectors are parallel? So we'll talk about the vector product and we'll see that vector product of parallel vectors is 0, but there is simpler way to check that if two vectors are parallel or not. Okay, so how to check? So suppose a bar and b bar are parallel. Okay, so let a bar and b bar are parallel. So if they are parallel, means a bar can be written as ax into I cap plus ay times j cap plus az times k cap. Okay, and b bar can be written as bx into I cap plus by times j cap plus bz times k cap. And now a bar and b bar are parallel, means if you stretch a, suppose a bar, the length of a bar is smaller than length of b bar. So if you stretch a, you will get b. Okay, if you stretch a with by appropriate amount, then you will get b. Right? For an example, suppose this is a bar and this is b bar, this is b bar. So if they are parallel, if they are directed in the same direction, then if you stretch this one by right amount, you can get b. This thing is clear? Yes, no? Okay, so that means b bar can be written as some constant k times a cap, a bar. Yeah, a cap is also fine. So b bar can be written as some constant k multiplied by a bar. And if you take b bar and a bar in component form, in resolved form, then bx will be equal to k times ax, by will be equal to k times ay, and bz will be equal to k times az. Right? So this will imply that if you take ratio of the components along x, y and z axis, the ratio will be equal. Okay, so if you have bx upon ax equal to by upon ay, and if that's equal to bz upon az, and suppose that is some constant k, okay, it will be this constant, then the two vectors will be parallel. Okay, so if it is so that bx upon ax is equal to by upon ay and it's equal to bz upon az, then these two are parallel. Okay, this is clear, everyone? Right? So this is how we can check whether two vectors are parallel or not. Okay, good. So this is how we check if two vectors are perpendicular, and this is how we check if two vectors are parallel. So what was the problem? So problem was vectors a bar is equal to this thing, b bar is equal to this thing, are functions of time, and the value of time, value of t, at which they are orthogonal, means perpendicular to each other. So So now we know how to check whether they are perpendicular or not. So if they are perpendicular, a bar dot b bar would be equal to 0, right? So just put a bar. So what is a bar? It's cos of omega t into I cap plus sine omega t into j cap, and take its dot product with cos of omega t by 2 times I cap plus sine of omega t by 2 with j cap, multiplied by j cap, and that should be equal to 0. Then multiply this out. So x component with x component. So you have cos omega t into cos omega t by 2, cos of omega t by 2, okay, plus sine omega t multiplied by sine of omega t by 2, and that is equal to 0. What is this thing? You tell me. Cos A cos B plus sine A sine B. What is this thing? If you remember trigonometry, cos A cos B, yeah, cos of A minus B. Very good. So that is cos of A minus B. So that is cos of, what's our A? Omega t, and B is omega t by 2. So cos of omega t minus omega t by 2 is equal to 0, and that is cos of 1 omega t minus half of omega t is 0. So that is cos of omega t by 2 is equal to 0. Okay. It's perpendicular. Alright. And cos of omega t by 2 is equal to 0 means omega t by 2 is equal to 90 degrees. Means let's write in terms of pi, that is in radians. So it is pi by 2. So omega t is pi. Okay, so what is omega? Omega is 2 pi by capital T, right? So 2 pi by capital T is equal to pi. Oh, we don't want all that, no? We don't want in terms of capital T. So omega t is pi. So this means that t is equal to pi by omega. So this is the answer. It's option A, right? This is clear. Okay, and this is simple. All right, good. So then if this vector 2i cap plus 3j cap plus 8k cap is perpendicular to vector this one, then the value of alpha is. Now we know that if they are perpendicular, then the dot product is equal to 0. So let's take dot product. 2i cap plus 3j cap plus 8k cap dot 4j cap, oh, they have written 4j cap first, minus 4i cap plus 4j cap plus alpha k cap, and that is equal to 0. So just multiply out. So it is minus 4 times 2, minus 8, plus 3 times of 4 is 12, plus 8 alpha is equal to 0. And what is this thing? Minus 8 plus 12 is 4. Okay, take it on other side. So 8 alpha is equal to minus 4, and that's why alpha is equal to minus 4 by 8. So that's minus 1 by 2. Right, that is minus 1 by 2. So this is the answer. Right. Okay, so this is simple. Let's see next one. The vector sum of two forces is perpendicular to their vector difference. In that case, the forces, okay, if they are equal to each other, are equal to each other in magnitude, are not equal to each other in magnitude, cannot be predicted. So this thing was given as a homework, right? I guess it was there in the, when we saw vector addition subtraction, right? So we can check it in different way. So vector sum of two forces. That means suppose first force is F1, second force is F2. So F1 bar dot F2 bar, F1 bar plus F2 bar, take its dot product with F1 bar minus F2 bar. And if this is perpendicular, means the dot product will be equal to what? It's equal to 0. Right? So vector sum of two forces is perpendicular to vector difference in that case. The two forces are equal to each other, they are equal to each other in magnitude, they are not equal to each other. So let's see. So you have F1 bar dot F1 bar, okay, plus you will have F1 bar dot F2 bar, okay, then F2 bar dot F1 bar, this will be minus, right? This thing will this thing multiplied by this thing is negative, plus F2 bar dot F1 bar, and you have F2 bar dot minus F2 bar, so that is minus of F2 bar dot F2 bar. So this thing is equal to 0, and then you have F1 bar dot F2 bar. So this is negative, okay, you have negative sign, here you have positive sign, so this thing will get cancelled out, okay, this thing is cancelled out. And if you take dot product of vector with itself, so what do you get? You will get F1 square, right, because it is F1 magnitude of first into magnitude of second, so F1 times F1 multiplied by cos of the angle between them. What's the angle between them? Is 0, cos 0 is 1. So this is F1 square, so F1 square, okay, minus you have F2 square, and this is equal to 0, that means F1 square is equal to F2 square, okay, and that means their magnitude is same. So this thing is clear. So they are equal to each other in magnitude is the answer. Okay, can we say that their direction is same? Can we say that they are equal to each other? Yes, no? Is the first option correct or the second option is correct? Option B is correct, right? What can we check? We can check whether their magnitude is equal or not. Yeah, option B is correct. Okay, so if the direction is same or not, that we cannot check from here, but common sense will tell us that if that direction is also same, then what will be F1 bar plus F2 bar? It is 2 times of F1 bar. What is F1 bar minus F2 bar? It will be 0. Okay, so they cannot be equal, they cannot be in same direction, right? This thing is clear? Yes, no, everyone? Okay, good. All right, so then let's see next one. Position vector of a particle is r bar is equal to a cos omega t into I cap plus a sin omega t into j cap. The velocity of the particle is directed towards the origin, directed away from the origin, parallel to the position vector, perpendicular to the position vector. Tell me. Actually, we have seen this question earlier. Okay, may not be the same exact question, maybe options were different, but this is the position vector of a particle which is moving in a circle, okay, which is performing uniform circular motion, right? It's performing uniform circular motion. So if it is performing uniform circular motion, then the position vector, okay, and the velocity, they are always perpendicular to each other, because position vector is directed along the radius, right? Yes, no? This is r bar and this is v bar. Okay, so answer is they are perpendicular to each other. So velocity is perpendicular to position vector. This is the answer. Now if you don't know, then you can check it, but I will not advise to do that, because I told you, just remember this one, right? Remember this position vector. But if you want, you can check it. How? So take velocity. What is velocity? So you know velocity is dr by dt. Okay, so that is equal to, take its derivative. So it is a cos omega t times I cap plus a sin omega t times j cap. Okay, so then when you take its derivative, the derivative of cos omega t is sin omega t multiplied by omega. Derivative of sin omega t is this one is minus cos omega t into omega. This one is cos omega t multiplied by omega. So you can write this is a omega multiplied by minus sin omega t times I cap, omega t times I cap, plus cos omega t times j cap. So this is v bar, and you will see that take dot product of r bar dot v bar, it will come out to be equal to 0, because that's how you check whether two vectors are perpendicular or they are not perpendicular, right? So if you just take dot product of this one with this one, it will come out to be equal to 0 definitely, right? And then that means that r bar and v bar are perpendicular to each other. Okay, this thing is clear. Right, so best way is just to remember it. Okay, remember what? This position vector. So every question of this type can be solved very easily. Okay, all right, so that's the scalar product. Then now there are some uses of scalar product. First one is finding the angle between two vectors. Okay, so this will be needed sometimes, few times. Okay, finding the angle between two vectors. How do we find angle between two vectors? So suppose we have these two vectors, a bar is equal to this thing in resolved form, ax into I cap plus ay times j cap plus az times k cap. This is a bar. B bar is equal to this thing, bx into I cap plus by times j cap plus bz times k cap. Then if you multiply them, okay, if you take dot product, so we know that it comes out to be equal to ax bx plus ay by plus az bz, right? And then we have definition of dot product, definition of scalar product, that this thing is equal to a times b into cos of theta. Okay, so a is magnitude of a bar, b is magnitude of b bar, right? So then you get cos theta equals to this thing divided by ab. Okay, ax bx plus ay by plus az bz divided by ab. So therefore what is theta? So it will be cos inverse of this remaining thing, means the term on the right hand side. So that is cos inverse of ax bx plus ay by plus az bz divided by ab. What is a and b? It's magnitude of a, right? A is magnitude of a bar, b is magnitude of b bar, right? And we know that how to find the magnitude of vectors. So magnitude of a bar is just square root of ax square plus ay square plus az square, and magnitude of b bar is square root of bx square plus by square plus bz square. Okay, so therefore we can write theta is equal to cos inverse of, what is this thing? So this thing can be said to be a bar dot b bar divided by ab. Okay, this thing is just a bar dot b bar, right, divided by ab. This is clear? Yes, no? Okay, good. This is how we find the angle between two vectors. So we can take an example for that. there is another use. Let's see first. Finding component of a vector along another vector. Okay, finding component of a vector along another vector. So this thing we already know actually, but let's see. So suppose this is a bar and this is b bar. Okay, what I can do is I can just say that b bar is directed along x-axis. Okay, because suppose these are two vectors, right? These are two vectors and I want to find out component of this one along this one. So then if I draw a perpendicular from there, starting from the tip of this vector on this vector, I will get component, right? So I'm drawing a perpendicular like this, so I get this much component. Okay, so that perpendicular meets at this point, so this much is the component of a bar along b bar, right? So then there is no loss of generality when I take b bar along x-axis. It is completely general. Why? Because suppose this is a bar and this is b bar, I find the component. Now if I rotate two vectors such that b bar is along x-axis, still the component will remain same, right? Because I am rotating both of them. This thing is clear? Okay, so component of a bar along b bar is a cos theta. Okay, theta is the angle between a bar and b bar. Then component is what? A cos theta. So if I multiply a bar with b bar, if I take dot product of a bar and b bar, then it is a multiplied by b multiplied by cos of theta, right? I know that. So then what I want to take is a cos theta. So what I will do, I will just say I will divide this thing by b. Okay, I will divide this thing by b. So b is what? Magnitude of b bar. Okay, then b and this b gets cancelled out. So what do I get? See, the component of a bar along b bar is a cos theta, and that can be written as ab cos theta divided by b. So b and b will get cancelled out. You will get cos of a cos theta, right? So what is this ab cos theta? It is a bar dot b bar. Okay, if I divide that by b, what do I get? B bar divided by its magnitude is the unit vector along b bar. It's the unit vector along b bar, right? What is component of a bar along b bar? It is a bar dot b cap. This thing is clear? Okay, component of a bar along b bar is a bar dot b cap, right? Yes, no? Okay, so for an example, suppose you want to find out component of whatever 3i cap plus 4j cap plus 5k cap. Okay, this is your a bar and b bar is equal to something else. So let's say 3i cap minus 2j cap. So how will you find component of this one along this one? So just take a bar dot b bar and divide that by magnitude of b bar. Okay, or you can find out the unit vector of b bar, that is you can find out b cap first and then multiply, take dot product of a bar with b cap. Okay, that's how. So I guess there are numericals, okay, previous year questions based upon this, so we'll see them. Okay, so let's see angle between two vectors. A bar is equal to 3i cap plus 4j cap plus 5k cap and b bar is equal to 3i cap plus 4j cap minus 5k cap will be. So tell me. So I will just say cos theta is equal to what? Ax bx. Okay, or I will write a bar dot b bar divided by ab. So this is a lengthy thing to do, but let's just do it once. Okay, so a bar is equal to 3i cap plus 4j cap, 3i cap plus 4j cap plus 5k cap, and this thing is equal to 3i cap plus 4j cap minus 5k cap. Okay, and in denominator you have square root of 3 square plus 4 square plus 5 square, 3 square plus 4 square plus 5 square multiplied by square root of, see this is magnitude of a, right, magnitude of a bar is this one, okay, ax square, square root of ax square plus ay square plus az square. Magnitude of b bar is square root of bx square plus by square plus bz square. Okay, so what is this thing? 3 times 3, okay, ax bx is 3 times 3, that is 9, plus ay by is 4 times 4, so that is 16, and az bz is 5 times minus 5, so that is minus 25, okay, and divided by something, because 16 plus 9 is 25 minus 25, so that is equal to 0. Then it doesn't matter what is the denominator, right? So denominator is something, okay, this is equal to 0. So if cos theta is 0 means theta is equal to, cos theta is equal to 0 means theta is equal to what? It's 90 degrees, right? So answer is option A. Okay, just tell me. All right, let's see next one. So this is a bar, okay, given a bar is equal to this and b bar is equal to this, the component of a bar along vector b bar is, so what is component of a bar along b bar? Component of a bar along b bar just equal to a bar dot b cap divided by b. Let's see. Oh, sorry, a bar dot b bar divided by b. So I wrote b cap also, and I am dividing by b bar, sorry, b also. Okay, so this is simple. 2i cap plus 3j cap dot I cap plus j cap and divided by magnitude of b, that is square root of 1 square plus 1 square, right? Bx is 1, by is also 1, square root of bx square plus by square. So that is 2 times 1 is 2 plus 3 times 1 is 3, 2 plus 3 is 5, 5 divided by this is root 2, okay. So component is 5 by root 2, that's the answer. So option C. Vishalini said option C. Yes. Okay, good. So this is simple, right? So this thing, okay, let's see this one. A bar is equal to this thing, b bar is equal to this thing. Then projection of a bar on b bar will be, so the component projection, it's all same. Okay, so it is a bar dot b bar divided by b, right? This is projection of, solve and tell me. This is projection of a bar on b bar. Option B. Okay, let's have answer from somebody else too. Option B. Okay, good. So it's option B. Okay, this thing is clear, everyone? Okay, good. So this is the scalar product and uses of scalar product. Okay, so we might require them, at least finding angle between two vectors we might require sometimes, okay, and also finding component of one vector along another vector, so we need to know. Okay, then let's talk about next kind of product between two vectors, so that is a vector product. Okay, so now the work is equal to force times displacement. This is very well known, right? But the example of vector product. So right now you might know, you might not know, so I am not giving any example. Okay, so the examples will come. Okay, all right. So let's define the vector product first. So what is the vector product? You multiply two vectors, resultant is also vector. Okay, you multiply two vectors, result is also a vector. Then the product is said to be a vector product. Now question is how to denote that, because we denoted scalar product. Let's suppose scalar product of A and B is C. So C is equal to, we said it's A bar dot B bar. Now we cannot use dot here, so that's why we make use of cross. So if A bar, product of A bar and B bar is also a vector, then how do we show that? C bar is suppose product of A bar and B bar. So we show it by a cross, and that's why it is also called as a cross product. Cross product. Okay. Scalar product is called as dot product. Vector product is also called as a cross product. Right. Now what's the difference between that and this one? So here, if you find the magnitude of resultant, it is magnitude of A multiplied by magnitude of B multiplied by sine of the angle between two. It is A times B times sine of theta. Okay, that one was A times B times cos of theta. Right, scalar was A times B times cos of theta. So here result is a scalar, result is a vector, means it has magnitude as well as direction. Okay, result is a vector, means it has magnitude as well as direction. What is magnitude? It's A times B times sine of theta. And how do you find the direction? To find out direction, we make use of a rule known as right hand thumb rule. Okay, we make use of a rule known as right hand thumb rule. So see, what's the right hand thumb rule? Take your right hand, keep it in direction of the first vector. Okay, then curl your fingers towards the second vector through the smaller angle. So if you have two vectors, this is one, this is another one, then there are two possibilities of angles between them. One is this one and one angle is this one. Okay, like this, right? One would be this angle, another would be this angle. Okay, so you need to take smaller angle. So keep your right hand in direction of first vector. Okay, like this. Curl the fingers towards the second vector and stretch your thumb. So your stretched thumb shows the direction of resultant. So that is the right hand thumb rule. Okay, keep your right hand along the first vector, curl the fingers towards the second vector through the smaller angle and stretch the thumb. Right, so this thing is clear? Yes, no? Okay, good. So then suppose this is A bar, this is B bar, this is A bar and this is B bar. If you find A bar cross B bar, suppose it comes out to be like this. This is C bar. Okay, this is A bar, this is B bar. A bar cross B bar is C bar and it comes out to be in this direction. Okay, its direction comes out to be like this, upward suppose. Then if you take B bar cross A bar, its direction will be downwards. Okay, B bar cross A bar will be directed downwards. You can check that. You can take two vectors in one plane, okay, in horizontal plane, let's say. So this is A bar, that's B bar. So if you do A bar cross B bar, right, this is A bar, that's B bar. If you take A bar cross B bar, the resultant is upwards. And if you do B bar, so sorry, this is B bar cross A bar, the resultant will be downwards. This is clear? B bar, okay, this is B bar, right, cross A bar, so resultant will be downwards. Okay, this is clear, right? So A bar cross B bar and B bar cross A bar, they are not equal. In case of scalar product, it was equal. A bar dot B bar was equal to B bar dot A bar because it's a scalar quantity. Here it's a vector, so the direction is opposite. Magnitude will be same. Magnitude is AB sine theta or BA sine theta, that is same, right? But direction is opposite. So A bar cross B bar and B bar cross A bar are opposite to each other. They are not same. Okay, they are not same. Okay, this thing is clear. Okay, good. Then now we need to find an expression for the vector product. So a bar is equal to, suppose this thing, b bar is equal to this thing. This thing means what? It is written in the resolved form. Okay, ax into I cap plus ay times j cap plus az times k cap. B bar is bx into I cap plus by times j cap plus bz times k cap. Then now I want to multiply them. I want to take their cross product. So I need to take cross product of unit vectors first. Okay, so let's take I cap cross I cap. Okay, I cap cross I cap. So what would be its magnitude? So its magnitude is 1 multiplied by 1 multiplied by sine of the angle between I cap and I cap. So angle is 0. That means it is sine 0. So sine 0 is 0. That's why I cap cross I cap is equal to 0. Similarly, j cap cross j cap is also equal to 0. K cap cross k cap is also equal to 0. So that means it is equal to a 0 vector, right? Remember, when we take vector operation and resultant is also a vector quantity, then we need to represent. If it is 0, still we need to put a bar on top of that, because we are taking vectors. We are taking multiplying, dividing, whatever, or adding, subtracting two vectors. So if result is 0 and it's a vector, okay, then we need to put a bar on top of that. This is clear, right? In case of scalar product, the resultant was a scalar. So if it is 0, we don't need to put a bar, but this is a vector product, right? So resultant is going to be a vector, so 0 bar. Anyways, so I cap cross I cap is equal to j cap cross j cap, and it's k cap, it is equal to k cap cross k cap, and it's equal to 0, right? So product of same vector with itself is equal to 0. Okay, product of a vector with itself is 0, and it also means that if two vectors are parallel, then the angle between them would be 0, so their cross product will be equal to 0. Okay, if two vectors are parallel, then their cross product is equal to 0. If two vectors are perpendicular, their dot product, means scalar product is 0. If two vectors are parallel, then their vector product is equal to 0. This is clear. Okay, good. Then I want to take I cap cross j cap. So next, I cap cross j cap, so it will be equal to k cap. How? Because if you take magnitude of this one, see what is I cap cross j cap, what will be magnitude of that? So it is magnitude of first, that is 1, into magnitude of second, that is 1, multiplied by sine of the angle between two. What is sine of what is the angle between two? 90 degrees. Sine 90 is 1. So I cap cross j cap's magnitude is equal to 1. And what would be its direction? So to find out direction, let's take I cap. This is I cap, this is j cap. Okay, I cap would be along x axis, j cap is along y axis. Put your right hand along x axis, curl your fingers towards y axis, stretch the thumb, it is along z axis, but it is along positive z axis, right? So I cap cross j cap will give you a unit vector along positive z axis, that is k cap. Okay, but if you do opposite thing, if you multiply j cap with I cap, it will give you minus k cap. Okay, similarly you can check this, j cap cross k cap will give you I cap, but k cap cross j cap will give you minus I cap. Okay, and k cap cross I cap will give you j cap, and I cap cross k cap will give you minus j cap. So now we need to remember this, but now you might say this is lot to be remembered. Okay, but it's not. See, now we can take them in an order, I cap, j cap, k cap. What we can do is we can use this little trick. So just draw a circle like this. Okay, put 3 dots and call them I cap, j cap, k cap. Okay, draw a circle like this, put 3 dots, call them I cap, j cap, k cap. Then draw the arrows pointing from I to j, j to k, and k to I. Right. Then now if you are multiplying this one with this one, if you are taking cross product of I cap with j cap, so if you are going along the arrow, then the result will be positive of the remaining one. Okay, and if you are going in opposite direction of arrow, then the resultant will be negative of the remaining one. Remaining one means k cap. So I cap cross j cap would be plus k cap, but j cap cross I cap is minus k cap. Similarly, if you are doing k cap cross I cap, that is j cap, but if you are going opposite to arrow, so I cap cross k cap is minus j cap. So this thing is clear? Yes, no, everyone? So then next thing, then I can find out an expression C bar is equal to A bar cross B bar, and we can check that. So there is a little long derivation. It will directly come to the result. Okay, so C bar is equal to A bar cross B bar, then you will get this expression for that. But how to remember that is using this determinant. Okay, so what is the determinant? So are you familiar with determinant, everyone? Yes, no? Okay, right. C bar is equal to, how do we write? What is C bar? It's A bar cross B bar. Okay, so it is determinant means just draw two lines, write I cap, j cap, k cap, then write the components of first vector, then write components of second vector. Okay, ax, ay, az, bx, by, bz. Then what is the result of this thing? What is this determinant? So this thing is equal to, now write I cap, so this is equal to, write I cap, then hide this row, sorry, this column and this row. Okay, hide this row and this column. Then what's you are left with? This thing, these four components, you can say. So then multiply this with this, do cross multiplication. So ay times bz minus by times az. Okay, ay bz minus by times az. Then put negative sign. So remember that, put a negative sign and write j cap. Okay, then hide this row and this column. So then you are left with these four. Okay, so then do cross multiplication, ax bz minus, write minus bx az. Okay, so ax bz minus bx az, and then write plus k cap. Okay, hide the row and column containing k cap, then do cross multiplication. So you have ax by minus bx ay, ax by minus bx ay. Okay, so this is how we solve the determinant. So is this thing clear? Yes, no? So this is how we solve the determinant, and this is equal to what? A bar cross B bar. This is equal to A bar cross B bar, right? So then now what is one use, the geometrical meaning of vector product? So geometrical meaning of vector product is an area of a parallelogram. Okay, so suppose two vectors represent two sides of a parallelogram. Suppose this is A bar and this is B bar. Okay, then angle between them is theta, angle between them is theta. Then C bar is equal to, suppose A bar cross B bar. This is the vector product of A and B. Now what I do is, I will draw a perpendicular from here like this. I will draw perpendicular from here, and then if I draw perpendicular from here, what will be magnitude of this one? The magnitude of this one is B sin theta. right? Magnitude of this one is b sine theta. This thing is clear. So if I take magnitude of this multiplied by b sine theta, I will get area of this parallelogram. So c bar is equal to a bar cross b bar. Then we know magnitude of c bar is equal to what? A times b multiplied by sine theta. So theta is the angle between a bar and b bar, right? Theta is the angle between a bar and b bar. So now see in this diagram, okay, in this diagram. So what I am doing is I am drawing a perpendicular from here. Okay, I am drawing a perpendicular from here. Okay. So now in this triangle PMS, what will be sine theta? So sine theta is opposite side divided by hypotenuse. Opposite side is SM, hypotenuse is SP. Okay. So then what is SM? So SM is equal to SP sine theta. Just take that SP on other side. So SM is equal to SP sine theta. Then what is SP? It is magnitude or its length of vector b bar. So it is b sine theta. Okay. Then you know area of a triangle is half of base into height. You know that. Okay. So now what I am doing is I have this parallelogram. So now if I draw this diagonal divides the parallelogram in two triangles, and those two triangles are congruent, they are equal. Okay. If you want to find out area of one triangle, then what you will do is you will find half of base multiplied by height. So base is this one, that is magnitude of side A. Height is this much, right? SM that is b sine theta. Okay, that is what? B sine theta. This thing is clear. So if you do half of A multiplied by b sine theta, you get area of one triangle, plus half of base into height is area of another triangle. That means if you do 1 times base into height, you will get what? Area of a parallelogram. Okay, this is clear. What is base into height? It is just A multiplied by b sine theta, and that is magnitude of a bar cross b bar. So magnitude of a bar cross b bar, or magnitude of vector product of two vectors, gives what? It gives the area of a parallelogram. Okay, whose two sides are represented by those two vectors. Okay, two adjacent sides are represented by those two vectors. So this is clear, everyone. Okay, and then if you want to find out area of a triangle, how will you find? It is just half of base into height, you know, and that's why if two sides of a triangle are represented by two vectors, then what is area of the triangle? It is just half of the magnitude of vector product of those two vectors, right? It is just half of the magnitude of vector product of those two vectors. So that's very, very simple. Okay. All right. Then let us see some problems based upon vector product. So vectors a bar, b bar and c bar are such that a bar dot b bar is equal to 0 and a bar dot c bar is equal to 0. Then a vector parallel to a bar is, tell me. A bar dot b bar is 0, a bar dot c bar is also 0. The vector product, if you take vector product of a bar and b bar, the resultant is perpendicular to plane of a bar and b bar. Okay, if you take vector product of two vectors, then the resultant is perpendicular to a bar as well as b bar, right? How do you find the resultant? To find resultant, you make use of right hand thumb rule. Okay, you put your right hand in direction of first vector, curl the fingers towards second and stretch the thumb, right? So the resultant is perpendicular to a bar as well as b bar. Okay, vectors a bar, b bar and c bar are such that a bar dot b bar is equal to 0 and a bar dot c bar is also equal to 0. Then the vector parallel to a bar is, so see, a bar dot b bar is 0 means a bar and b bar are perpendicular to each other, right? A bar dot b bar is equal to 0 means A bar is perpendicular to B bar. Okay, right? Because if two vectors are perpendicular, then we know that their dot product is equal to 0. Okay, A bar and C bar, A bar dot C bar is 0, means A bar is perpendicular to C bar also. But now you want a vector parallel to A bar. So if you multiply B bar with C bar, if you do B bar cross C bar, then the resultant is perpendicular to B bar as well as it is perpendicular to C bar. Okay, when you take vector product of two vectors, the result is perpendicular to B bar as well as C bar. For an example, just check. Suppose this is B bar. B bar is directed like this. C bar is directed like this. Okay, if you take vector product of these two, make use of right hand thumb rule. Tell me what will be the direction of B bar cross C bar. Into the plane of board or outside the plane of board? What will be the direction of B bar cross C bar? Outside the plane of board, right? And that is perpendicular to A bar, sorry, that is perpendicular to B bar as well as C bar. Okay, that is perpendicular to whole plane. Into the plane or outside the plane, it's perpendicular to whole plane. That means it is perpendicular to B bar as well as C bar. Okay, and it's given that A bar is perpendicular to B bar, it is perpendicular to C bar also. That means it is perpendicular to whole plane. Okay, whole plane containing B bar and C bar, right? So what would be a vector parallel to A bar? It will be B bar cross C bar. Because if you take B bar cross C bar, it's perpendicular to both. This is clear, everyone? Right, good. Let's see next one. A bar and B bar are two vectors and theta is the angle between them. If magnitude of A bar cross B bar is equal to root 3 times A cap A bar dot B bar, then the value of theta is. So let's solve this. Okay, so it's given that magnitude of A bar cross B bar is equal to root 3 times of A bar dot B bar. What is this thing? AB sine theta. Okay, magnitude of vector product of two vectors is AB sine theta. It is equal to root 3 times AB cos theta, right? So AB and AB gets cancelled. Take cos theta on this side. So sine theta divided by cos theta is equal to root 3, means this is tan theta equals to root 3. Okay, so what is theta? It is 60 degrees, right? We know that tan of 60 is root 3. Correct? Yes, no? Okay, good. So this is simple question. It is from NEET, or you can say AIPMT 2007. Okay, so very simple. Let's see next one. If angle between vectors A bar and B bar is theta, then the value of product, this thing is equal to okay, tell me. You have B bar cross A bar, and then you take its dot product with A bar. Option C. Okay, option C. All right, actually its answer is 0. Its answer is 0. See, the reason is this B bar cross A bar, whatever it is, whatever is the magnitude, it is perpendicular to A bar as well as B bar. we just saw this. So if this is perpendicular to B bar, suppose this is C bar, okay, C bar is equal to B bar cross A bar, and this is perpendicular to A bar. So then what will be C bar dot A bar? So it is equal to C multiplied by A multiplied by cos of theta. And if this is perpendicular to A bar, means what? It is cos of 90. Cos 90 is 0. That's why this is 0. Right? So we just saw when you multiply two vectors, when you take vector product, the result is perpendicular to first vector as well as second vector. So this thing is perpendicular to A bar as well as B bar. So if it is perpendicular to A bar, then you take its dot product with A bar. The result is equal to what? Result is equal to 0. Right? Okay. So answer of this thing is 0. Right? This is also very, very simple. All right. Let's see next one. If the magnitude of A bar cross B bar is root 3 times A bar dot B bar, then the value of A bar plus B bar is, okay, so this is different. All right. So the magnitude of A bar cross B bar is equal to root 3 times of A bar dot B bar. So this is AB sine theta, it is equal to root 3 times of AB cos theta, and from this one, so AB and AB gets cancelled. Take cos theta on this side, so sine theta by cos theta is tan theta. Again tan theta is equal to root 3. This is just like the earlier question that we saw. Therefore theta is equal to what? 60 degrees. Okay, theta is equal to 60 degrees. And then they ask what is the magnitude of A bar cross B bar, A bar plus B bar. What is the magnitude of A bar plus B bar? So we know what is the magnitude. Square root of A square plus B square plus 2AB cos of theta, right? And what is theta? Theta is 60. Okay, so that is square root of A square plus B square plus 2AB cos 60. What is cos 60? Cos 60 is half, no? So half times 2 is 1. So it's square root of A square plus B square plus AB. Right? Square root of, or we can say A square plus B square plus AB raised to half. That's the answer. Which one? It is option A. Okay. This one is clear. Okay, it's all similar, right? Okay, let's see next one. The resultant of A bar cross 0 will be equal to, tell me, is it 0? Is it A? Is it 0 vector? It's unit vector. Okay, but now if they had written a vector over here, then it is 0 vector. Are you getting this? What is this thing? Resultant of A bar cross 0. Is this 0 or 0 vector? So this thing is definitely 0. Okay, A bar multiplied by, so wait. Or changing like anything. A bar cross 0 bar is definitely 0 because you are taking vector product of two vectors. Now see, now I put this cross sign and this is a scalar, 0 is a scalar. If I write 2 times of A bar, is this a scalar or a vector? It's a vector. 1 cross A bar is a vector, right? So what will be 0 cross A bar or A bar cross 0? Now this cross or dot, it doesn't matter here, okay, because you're multiplying with a number, right? This one was a vector, here it's a number, so number times a vector is what? It's a vector, no? Okay, so what's the answer? 0 vector. Your earlier answer was correct, right? Okay, good. So answer is 0 vector. All right, but I know that you thought in this way, okay? A bar, I'm sure that you must have thought in this way. This A bar cross with 0, or this is my guess at least, it's equal to, the resultant will be 0 and it's a vector quantity because you are multiplying two vectors. But then I just pointed out that this is a scalar, okay, this is not a vector, but still the resultant is 0 because a vector multiplied by just a number is equal to what? It is a vector quantity, right? So am I correct that you thought in that way? Yes, no? Okay, good. All right. Let's see next one. A vector A bar points vertically upwards and vector B bar points towards north. Then A bar cross B bar is directed. Tell me, one is upwards and B bar is towards north. Then A bar cross B bar is directed towards west. Okay, let's check. Let's draw east, west, north, south. Okay, or better ways, I'll draw it like this. Oh, a 3D diagram. So this is east, west, north, south, and this is vertically upwards. Okay, so what's given here? Vector A points upwards, A bar is upwards. Okay, so let's say this is A bar, and B points towards north, B is towards north, so this is B bar. This is B bar. So A bar cross B bar is directed towards, A bar cross B bar towards west. Somebody said towards west, Yamini said, right? So that's correct. Okay, good. All right, very good. So everybody, this is clear? Good. All right, let's see next one. Two vectors A bar and B bar are inclined to each other at an angle theta. Which of the following is a unit vector perpendicular to A bar and B bar? So we know that what is a vector perpendicular to A bar and B bar? Okay, so if C bar is equal to A bar cross B bar, A bar cross B bar, okay, then C bar is perpendicular to A bar as well as B bar. We know this thing, right? But we want unit vector. So what will be unit vector perpendicular to A bar and B bar? It will be C cap. How will you find it? So C bar is equal to A bar cross B bar. Okay. First of all, what is C cap? It is C bar divided by its magnitude. Okay. So that is equal to, what is C bar? A bar cross B bar, and therefore magnitude of C bar is magnitude of A bar cross B bar. And what is magnitude of A bar cross B bar? AB sine theta, and that's why answer is A bar cross B bar divided by AB sine theta. Right, so which one is correct? It's option 3 or C. Okay, this is clear? Yes, no? All right, good. Let's see next one. The unit vector perpendicular to vectors, this one and this one is. So how do we find it? First of all, we need to find out, let's say C bar is equal to A bar cross B bar. How do we find C bar then? So determinant. Okay, these are all very simple questions, right? Determinant of I cap, J cap, K cap, AX, AY, AZ, BX, BY, BZ, right? AX, AY, AZ, BX, BY, BZ. And what's that? That is equal to determinant of I cap, J cap, K cap. What is AX? 4, 4, 3, 6, and this is minus 1, 3, minus 8. So 4, 3, 6, minus 1, 3, minus 8. Okay. Then let's solve the determinant. So therefore you have C bar is equal to I cap multiplied by this with this minus this with this. So minus 24 and minus 6 3s are 18. How much is that? 42. Minus 42 I cap. Okay. Then minus 42 I cap. (24 plus 18), right? Yeah, that's correct. Okay, so then minus J cap, this with this, 32 minus 32 minus 6, so that's minus 38. J cap, no, that will be plus, no, because it's minus J cap multiplied with this thing. Okay, and then K cap multiplied by 4 times 3 minus 3 times minus 1, 3 times minus 1, oh, this one is wrong, no? Minus J cap multiplied by 8 4s are 32 minus 32 minus 6 times minus 1 times 6, so that is minus 6, minus minus plus, so that will be 26 J cap. And what about this one? So K cap multiplied by 3 times 4 is 12. Okay, minus 1 times 3, how much? Plus 3, 15. So 15 K cap. Okay, is that correct? Yes, no? So this is C bar. You want unit vector in that direction. So C cap is this thing, minus 42 I cap plus 26 J cap plus 15 K cap divided by its magnitude. So square root of 42 square plus 26 square plus 15 square. Okay, whatever that is. So check whether it's one of these things. So maybe this is 49, 15.3. Okay, 51.3. No problem. So maybe this thing is wrong. Just check before that, before coming to conclusion, whether this algebra is correct. This thing is correct. Okay, let me check this once. It's I cap multiplied by minus 8 times 3 is minus 24. Minus 6 3s are 18. So that's correct. Minus 24 minus 18. So that's 24 plus 18 is what? 42, no? So that is correct. Okay, so minus 42 I cap. Then J cap minus J cap multiplied by O times 8. So that's minus 32. Minus 32 minus 6, right? Minus 6. So that is plus 6. So that is minus 26, and negative sign of J cap plus 26 J cap. So that's correct. And K cap multiplied with 4 times 3 is 12 minus 3. So that is also plus 15 K cap. Yeah, so that's correct. No problem. Okay, so unit vector will be this one. So maybe these options are incorrect. Okay, all right. But so the purpose is just to find out, I mean, just to understand how to find out unit vector perpendicular to two vectors. Okay, right, this thing is clear. Okay, good. All right, next, if I cap plus j cap plus k cap and 3 I cap are two sides of a triangle, then the area of triangle is, tell me, I cap plus j cap plus k cap and 3 I cap are two sides of a triangle, then area of a triangle is. So we know that area of triangle, so suppose this one is a bar is equal to I cap plus j cap plus k cap and b bar is equal to 3 I cap. Okay, the area of triangle, area is half of the magnitude of a bar cross b bar. So first of all, find out a bar cross b bar. So that is equal to, okay, I cap j cap k cap. A bar cross b bar is I cap j cap k cap. Then the components of this one 1 1 1 and component of this one is 3 0 0. Okay, all right. So then you have I cap multiplied with this thing times this thing is 0, this thing times this thing is 0, so this is 0. Okay, so this is 0 plus j cap multiplied with minus j cap multiplied with what, 1 times 0 minus 3 times 1. Okay, so 1 times 0 means 0, 0 minus 3 times 1 is minus 3. Okay, plus you have k cap multiplied with 1 times 0 minus 3 times 1, so that is minus 3. So the answer is 3 j cap, okay, 3 j cap, then minus 3 k cap. Okay, this is a bar cross b bar. So what will be magnitude of this one? What will be magnitude of this one? So magnitude of a bar cross b bar is just equal to square root of, sorry, magnitude of a bar cross b bar is just equal to what? It's equal to square root of 3 square plus 3 square, right? 3 square plus minus 3 square, that is equal to 3 root 2, right? So it is equal to 3 root 2. Okay, and then you wanted half of that, so we want half of that, so just multiply with half. So this thing divided by 2, this thing divided by 2, that is equal to, this was 3 root 2, so it's root 3, not root 3, 3 root 2 divided by 2, so this 2 by root 2 is root 2 in the denominator. So answer is option 3. Okay, so it's 3 by root 2, right? Okay, this thing is clear, everyone? All right, good. That's very simple. Okay, then two sides of a parallelogram are represented by these two vectors. Then what is the area of parallelogram? So area of parallelogram, I'll just leave it for you. Area is just equal to what? The magnitude of p bar cross q bar, right? Or let's solve it. Okay, so it's I cap j cap k cap, and what is this thing? So first of all, let's find out p bar cross q bar. So it's equal to I cap j cap k cap, the determinant I cap j cap k cap, px py pz, so that's 5 minus 4 3, and qx qy qz, so that is 3 2 minus 1. Okay, so just multiply it out. So what's the answer? It's I cap multiplied by minus 4 times 1 is 4, 4 minus 6, okay, minus j cap multiplied by 5 times minus 1 is minus 5, minus 5, right? Then minus 9, so minus 9 plus k cap multiplied by 5 times 2 is 10. 10 minus 12. Okay, 10 minus 12. Okay, that is minus 2 I cap. Then this is 14 minus 14 times this negative sign plus 14 j cap, and then you have minus this is plus 12, right? 12 plus 10 is 22, so plus 22 k cap. Okay, so this is p bar cross q bar, and you want area. So area is just magnitude of that. That is square root of 2 square plus 14 square, 2 square plus 14 square plus 22 square. What is that? 2 square is 4, 14 square is how much? 196. So that's 200. 200 plus 22 square. 22 square will be 4 times of 121. 121 times 4 is what? 484. 484. 484 plus 200 is 684. So it's square root of 684. So that's the answer.